Today, again, we're going to do an abbreviated lesson on 9.4, 9.5, and so 9.4, we're going to talk about simplifying, multiplying, dividing rational expressions. First of all, we have to understand what is a rational expression. Guys? So a rational expression is in simplest form when the numerator and denominator are polynomials that have no common factors. Slightly differently than the way it's worded in the book, but same meaning. It chose to use the word factors. I think those are a term that we're more familiar with. In the first example here, the directions are actually in the first two. The directions say simplify each of the following and state any restrictions on the variable. So in order to simplify this, we need to rewrite our polynomials into factored form. And if a quadratic is going to factor, almost always it's going to have to factor like this. Okay? Sometimes it's easier to find one of them that factors and then use that as a tip to how to factor the other one. Okay? And so top or bottom to you, which one looks the easiest to factor? Top, okay. This says our signs have to be the same as this, so they're both positive. The only way to get x squared is x times x. Do you agree with that? So the first two have to be x's. And then I need the factors of 6 because the signs are the same that add up to 5. 3 and 2. Okay? And so now we go to factor the bottom. If this is going to simplify, then one of these has to be one of the factors down here. This is not a difficult one to factor either following those same rules. Since that sign is negative, one of these is positive and one's negative.
Isn't it the same except for the 3?
Still, the only way to get x squared is x and x. Now, what were you wanting to say?
Isn't it the same numbers, it's just the 3 is negative?
Yep, that's right. Now we want the factors of 6 that subtract to give me a negative 1. So that's 3 and 2, and I need the 3 to be negative, so the 2 would go here. Okay?
And then the 2's can cancel.
Right. Before I do that, though, probably we should answer the second part of this question. State any restrictions on the variable. Because we don't want to forget about something we canceled out. Right? Everything that's in the denominator now has to be positive, or has to not be 0. And so if x is,
X cannot equal 0.
well, x can equal 0 because 0 plus 2 is 2, and 0 minus 3 is negative 3, and 2 times negative 3 is negative 6. So that's okay, but what can't x be?
X cannot be negative 3.
It can't be a negative
Negative
2, and it can't be a positive 3, because if I put 3 in here, 3 minus 3 is 0, and that creates a 0 in the bottom.
Yeah,
If I put negative 2 in here, negative 2, right here I meant, negative 2 plus 2 is 0, and that creates a 0 in the bottom. Okay? So there's my restrictions. Now you said, hey, these are exactly the same factors, so let's cancel them. That's correct. Let's do that. And you can do it first. It's just that you don't want to forget about this factor. Just because it canceled out doesn't mean we don't have to worry about it. It still creates a 0 in the bottom in the original, and that can't happen. And so we're left with x plus 3 over x minus 3. No. No. I'm glad you said that, though,
Oh, yeah.
because you're not the only one who's ever done something like that.
Yeah.
We cannot cancel them.
Yeah, I forgot.
They have to be factored form, and these as a factor are x plus 3 and x minus 3. As individual terms, they were the x and the 3. But the individual terms aren't factors, and we cannot cancel them that way. That would be like saying 5 plus 2 over 5 minus 2. 5 plus 2 is 7, 5 minus 2 is 3. So the answer is 7/3, right?
Yeah.
Yet if I canceled all this out, I get a -1, you were saying,
Yeah.
okay? But you're not alone, that's why I'm taking time on this thought. I'm glad you mentioned that. A lot of people wanna cancel those individually, you cannot do that, okay? You have to cancel them as factors. That's why back here, we didn't cancel them out here and say, oh, my 6's are gone, my x's are gone, I'm left with 5. 5 over -1 would be -5. And that's not what we got, okay?
So, can we use is the zero property theorem? or-
Zero product property?
Yeah, would that be, used here?
That's
Because
what we
it's-
are using.
It's just division instead of multiplication, there's only work with multiplication.
That's what we're using here, when we're saying the bottom can't be 0, and so that means x plus 2 can't be 0, and x minus 3 can't be 0.
Yeah.
And then we're solving that, but we're just
So,
doing it in our head since we've done a few of them before. We
yeah.
got -2 and 3.
Okay, but I was wondering, like, you know how it's just like that, but it's dividing instead of multiplying. I was wondering, or is there like a zero quotient property or just zero product?
No. Unless I'm really confused on what you're saying.
Yeah.
I don't think what you want is exist. Yes.
Alright, so how we write this is, x plus 3, divided by x minus 3.
Yep.
And then that's it, and x can't equal -2 or 3.
Right.
That's the answer.
Yep. So this is the answer in simplest form. And these are our restrictions. So those are both answers to the question. Okay? So we'll do that division or multiplying one in just a second. Let's simplify this. Again, if this quadratic is going to factor, it has to factor like this. Since there are no common factors all the way through, and there are none all the way through here, it's going to factor as a product of two binomials. Which one, top or bottom, is going to be easier to factor? The bottom. And so, plus sign means both signs are the same as this. So plus and plus. The only way to get x squared is x and x. Factors of 3 that add up to 4 are 3 and 1. Okay? All right. Now the top one is a little different. Okay? Signs have to alternate, but I have a number here. Okay? I agree I have to have an x in here yet, but there might be a number in front of one of them. Not might be, there has to be a number in front of one of them. Okay? And then the factors of 2. So some of you probably are really good at this. All right? I've had a lot of experience with it. I can do it pretty quickly. But some of you not so much. So what I suggest is look at these two. Okay? And the tip is, if this simplifies, one of the top ones has to match one of the bottom ones, or both. Could x plus 3 be one of my factors to this top?
No.
No. Because 3 is not a factor of 2, is it? But x plus 1 could be, couldn't it? So if that was x plus 1, we're just going to pretend it was. And we're going to say, what would the other one have to be? Well, to get 3x squared, what would have to go here? 3. And to get 2, what would have to go there? 2. Okay? Now let's test it to see if it does work. Did you say but?
Yeah.
But what?
Alright. Wouldn't that be a positive x? Like, wouldn't that come out to be positive x instead of the negative x? Yeah. For like 3x. Positive 3x minus 2x.
Yeah, you know how I fix that? I did make this up. My bad. Let's change that to a plus.
Yeah, because I was wondering,
Yeah.
you can just have 3x plus 2 and then minus 1 and that would factor.
Yeah,
It doesn't have any common terms.
My bad. When I made it up, I didn't do it all out. I just did it in my head. You see what happens. Someone who's pretty good at it doesn't, he makes mistakes. That's why I want you to write them down. So now if we test it, you've already done that. You're good at that. Good. 1 times 3x is a positive 3x. And negative 2 times x is a negative 2x. And that's why we notice I should have had a plus x there, not a minus x. Okay? So we'll just make that little switch in our notes. And when we're done, I'll go back to my notes and make that a plus. All right? Any questions on that? But the idea is, you factor the easy one first, and then use that as a tip to help you find the harder one. Yeah.
Do you only state restrictions for denominators? Because like for 3x minus 2, that'd be different than those other ones.
Oh. I'm sorry. I was still looking at my problem. Go ahead, say again.
Like, to get restrictions, you only, it's only from the denominator, right?
Right.
Go to the bathroom.
Yep.
Back by 0.
Yep. Yes, that's correct. Okay? And so that's what we want to do right now. Now that we've factored it, we're going to say x cannot equal what? Okay, -3 and a -1. The -1 came from here and the -3 came from here. Okay? So there's my restrictions. And then if I cancel like terms, not like factors I should say, I'm left with 3x minus 2 over x plus 3.
Is that the final answer?
It is. Yeah, that can't be canceled anymore or reduced anymore. Okay? All right. Multiply. We'll do the division one in just a minute. Multiply and state any restrictions on the variable. Again, we want to factor. I didn't make this one up, so we'll see what we get. We still need to factor. How do we factor x squared minus 4?
Where you you could write it out, just,
Well, remember I said, unless, are there any common factors? Any common numbers in both or variables? Nope, so it would have to factor like this, right?
yeah, it's a perfect square, and there's some way that you showed us how to do those fast.
Okay, and it's a difference of 2 squares, right?
Oh, yeah.
So we have an x and an x. To get a negative, we must have opposite signs. And the factors of 4 that subtract to give you 0. 2 and 2. That's if we follow all the rules. If we just recognize there's a difference of 2 squares, then it's going to be the square root of each of them. In both cases, 1 plus and 1 minus. So if I were to FOIL that, those factors, the O and I would cancel each other out. So how does this one factor? X squared minus 1.
X plus 1 and x minus
Same concept, isn't it? It's a difference of 2 squares. And so it's going to be x plus 1 and x minus 1. Okay, and then on the top, on the other side, x plus 1, nothing in common there, is there? So nothing factors out of that. That's already factored. What's in common in these two? An x. So if I factor that x out, what's left?
X plus 2.
X plus 2. Okay? So there's our factors. If you're not good at factoring, this lesson will be hard for you. And so you'll have to rely on tips and doing the easy ones first and using that to cheat to try to figure out what the others will be. Okay? If you're really good at factoring, this will be real easy for you. All right? Now, restrictions.
Both 1 and -1.
Okay?
And would it be -2?
Do you agree? Negative 2?
Or,
Wouldn't it be 2 and negative 2?
2, why 2 and negative 2? Where are you looking? Up here?
Yeah.
But that's not in the denominator.
I was thinking of that.
Well, like, when you
So
have
it would
this,
be negative 2.
X can't be 0? Okay, why?
Oh, yeah.
In the denominator, it's multiplied by x,
Yeah.
and if x is
Okay,
zero-
I have an X all by itself here, right? And if I made X 0, then it'd be 0 times some number would make it 0, right? So you're right, it can't be 0, and it can't be
Negative.
-2.
That's why I got my negative 2.
Yep. I thought it was, but I just wanted to confirm that we're all looking at the same thing. Okay? So there's our restrictions. Now, let's go back and simplify. Remember, if you have 2/3 times 1/2, we can multiply straight across, right? And then reduce. Or instead of doing that, we can look this way and reduce common factors. 2 goes 2 goes in both of those, so I cancel those out. I get 1 times 1, and 3 times 1 is 1/3. Okay? Box that in so it doesn't get messed up with all the other stuff. So if we go back here, I have an x plus 2 on top. I have an x plus 2 on the bottom.
And x plus 1.
X plus 1 on the bottom, x plus 1 on top. And so, anything else in common? No? So this is equal to, on top, x minus 2 is left. And on the bottom, what's left?
X times X minus 1.
Okay, x times x minus 1. Good. I was afraid we overlooked that x. Okay? So there it's reduced. We could look to see if they went ahead, Megan, and multiplied that back through. They possibly could have. I wouldn't, but they could have. Okay? So after you do one and you check it, you'll know how they dealt with that. Okay? Any questions on multiplying? Okay, dividing, stating restrictions on the variable.
No, they wouldn't. I don't think they would. But they would multiply that.
Let's do this. 2/3 divide 2 sevenths. How do we do those fractions if we could not use our calculator?
2/3 times 7/2.
Okay, we would use the KCF, right? Keep, change, flip. Keep the first fraction, change the sign to multiply, and flip the second fraction. So again, my 2's would cancel, I get 7/3. Okay? I need to use the same concept in this problem. Okay? All right. So, I want to use this concept. I'm going to move it now. You've seen it. If you need to see it again, let me know. This is, I always hesitate what's going to be best for you. Should we factor it first and then flip it? Should we flip it first and then factor it? Factor first, okay? So on the bottom, I'm going to start at the bottom, that's going to be the easiest. Now this top one, that's already done, right? On the bottom, how does this factor? Okay, it's the difference of 2 squares, right? So x plus 4 and x minus 4. And then on the top, factors, the signs are opposite.
X minus 2 and x plus 5.
The only way you get x squared is x and x. And the factors of 15 that subtract to give me 2.
Minus 3 plus 5.
Yeah. It was a positive 2, so my 5 has to go next to the plus sign. My 3 over next to the minus sign. Okay? And then, how do we factor 3x minus 12?
Take 3 out.
Take a 3 out of each. Good. Leaving me with an x minus
So you can take x minus 4.
x minus 4.
Flip it.
Yeah.
Okay? Now, at this point right here, I think it's important that we start this process. X cannot equal what? Okay, right here, it can't equal -4 and it can't equal +4, right? And when I go over here, X can't equal,
One negative one.
a +4, right? Right here, X cannot equal +4, can it? We'll get that in just a second. Right? Well, we already have the +4 in this, so we're covered right now. So let's go ahead and flip this, and so we get X plus 5 and X minus 3 over X plus 4 and X minus 4, sorry if I'm in the way. And now instead of divide, we're in times, and we're going to flip this over. And Max was really eager to tell us what?
Is it negative one's a restriction?
It is. Now when we flip this over, we just put a new number in our denominator, didn't we? And it still can't equal 0. And so in this case, X cannot equal -1.
So, yeah.
Okay? Do we have any common factors?
Yeah. X minus 4.
X minus 4. Leaving me on top with X plus 5, X minus 3, and a 3. I'm just going to move that 3 out front. Whenever there's a lone term like that, I like to just put it up front. Okay? Doesn't mean it's more right than anybody else's. It's just what I like to do with it. X plus 4 and X plus 1. Okay? Our restrictions and our fraction is left, our rational expression. Okay? Any questions on that? Okay, I think that's it for this one. Yep. Let's go to this one. Plus. All right, lesson 5. We're going to add, subtract rational expressions, and then simplify complex fractions. Okay? So again, to add fractions, I just put a couple simple ones here. Excuse me. To help you remember, to add fractions, we must have a what? Common denominator. So we're going to look at these denominators, 3 and 4. The smallest number that they both go into is 12. And that's 4 times 3, and then again 4 times 3. And so now we have a denominator of 12. And I get in the habit of writing it as a single fraction. I think it's going to work better for what we have to do later. And so the 2 we had to multiply by 4, so that gave me 8. And the 5 we had to the 5 we had to multiply by 3, so that gives me 15. And then because these are just numbers, we can go ahead and add them. What's 8 plus 15? 23 over 12. And we'll just leave it. That is actually called a simple fraction. I know a lot of you think it's improper, which it is, but it's still a simple fraction. It's 23 and 12 have no common factors other than 1. Okay? And if we write it as a mixed number, sometimes that's more complicated. And when we get down to these, actually the rest of them, we cannot write them as mixed numbers. Okay? So, looking at the next one now, between those two, what is common? What's the smallest, I should say, that they both go into?
X squared.
X squared. Yep, there's one X here, so I need that X. But when I get over this one, I need 2 of them, so I need an X squared. Okay? So this one already has that denominator of X squared, doesn't it? And so that plus 5 is still going to be there. Okay, in this one, what do we have to do to the bottom to make it x squared?
Times X.
Times it by x. So we multiply the top by x, we get 3x. We want to be careful if we say square it, because then in our mind we might be thinking, oh, we have to square the top.
Yeah.
And that's not really what we're doing. We're really multiplying it by x, which I agree, the result is x squared, but we multiplied it by x. Okay? And that's our simplest form. If they said to state any restrictions on the denominator, then we could go ahead and do that. In this case, just x couldn't be 0, right? I don't think they're going to ask you to do that in these, but if they do, you'll have lots of practice on the first few. All right? My computer is so slow. Let's go ahead and factor this first. Let's start with this one. What does it have in common?
3x.
A 3, right?
3.
Leaving me with x plus 5, right? Same concept works here as it does when we're simplifying. Factor the easy one first. That will give you a hint that will probably make the other one easier to factor. But first of all, what does 3, 21, and 30 all have in common? 3. A 3. So if we take that out, I'm just going to do it right here. I'm left with 7 and 10. Do you agree? All right. So when I go to factor this, I have a 3. I can't forget that. Um, 5 and 2. I'm looking at this though, thinking one of them is probably
Yeah.
x plus 5. Okay? And so the other one would have to be x plus 2, and they do add up to 7. Right? So it does work. Okay, so now let's write our common denominator down here. I'm going to start on this side. This is literally how I do it. I just start with the first fraction, and I start going through. I need a 3. I need an x plus 5. I need an x plus 2. Oops. Then I go over to this one, and I continue. I need a 3. Oh, I already have it.
So like if that was,
I need an x plus 5. I already have it.
so like if that was a 4 on that side, it would usually be 12.
Yep.
Okay.
Yeah, he said, in case you didn't hear it on the microphone, he said if that 3 was a 4, then I would need a 4 down here, and then 4 times 3 would be 12. Okay, so I'd have a 12 there instead of a 3. All right, and if this x minus 5 was x, I'm sorry, if x plus 5 was an x minus 5, then I need an x minus 5 here. So I start with the first fraction, and I write everything down, because I need all of that. And then I go to the next one, and I keep adding every factor I don't already have. Okay? Or if I had a squared here, then that would mean I need 2 of those x plus 5s, and so I would then square this one. Okay? All right, so let me clean this up just a little bit. And let's go back. The top, or the first fraction, oh, I'm sorry, I never rewrote the top, did I? There we go. The first fraction and the final fraction have all the same denominator, don't they? So we don't have to multiply anything by the top of the first one over here. And so we just have a 1 and plus, and then the second one, what's missing in this denominator that I have down here? X plus 2. So that 4x has to be multiplied by x plus 2. Okay? And so if I clean that up a little bit on top, I get 4x squared plus 8x. I'm thinking they probably wrote these, multiplied them out. And that's okay in this case, because if I multiply this out, what do I get? Remember, we made it look like that. What
Yeah.
was it before we did it?
3x squared plus 21x plus 30.
Yeah, 3x squared plus 21 plus 30, right? 21x, sorry. And you're right, that squared should be there. 3x squared plus 21x plus 30. And if you didn't hear me, I didn't write the square down right away on the top, and I just added that in. So if we clean up that top, we get 4x squared plus 8x plus 1 over 3x squared plus 21x plus 30. And as hard as you may try, that does not simplify anymore, because we already looked at it in factored form. And there's nothing there. Okay? All right. This is so annoying. Okay, now, do you want me to take time to do number 4 here? The only difference between it is a minus instead of a, yeah, actually I did that like 30 seconds ago on circle before, is the minus instead of the plus, but otherwise it's exactly the same. So, show of hands, you want me to do this one? Okay. And let's go to this one. As you can see, I obviously forgot to finish writing my examples down. This is the concept. Just make up something really simple here. One over x over 3 over x. So we have a fraction within a fraction, right? What's that?
Fractionception.
Fractionception.
Inception, both fractions.
Okay.
How about you could have fraction, both fraction?
We don't want to leave our answer that way. That's the point of this problem. So remember, keep, change, flip. First fraction is 1 over x. Times the, instead of divide, and then flip the second fraction. So it's x over 3. What happens?
X is canceled.
X's cancel. I get 1 over 3. Okay? And so that I don't end up in a real mess here, I will not make one of these up. So let's instead grab one here. 1 over x plus 1 over y. 1 over x plus 1 over y over 2 over y minus 1 over x. Okay? 1 over x plus 1 over y divided by 1 over y minus 1 over x. The problem with this is the keep, change, flip. We can't apply that yet. Okay? Because these are separate fractions. It's not one fraction. And these are separate fractions. So what we want to do first is combine them to make them one fraction. So we have to have a common denominator. And what's that going to be?
XY.
XY. And so what was the first denominator missing that the new one has? See this denominator here? It's missing the y that this one over here has. So we multiply top by y, we get 1y or just y. And then plus, what was the second fraction missing that this has? The x. So 1 times x is x. So we get y plus x, or x plus y, same thing, over xy. That's what this top turns into. Divided by. Again, now, we want to have a common denominator. So y and x are my denominators. What's my common denominator? xy. What's the first one missing that this has?
X.
An x. So 2 times x minus, what's the second one missing?
Y.
And so I get 1y, which is just y. Now we can apply the rule, keep, change, flip. So we keep the first fraction, change divide to times, and flip the second one. Oops, there, that's 2x minus y, not 2y. 2x minus y. Okay? What happens now?
Cancel X, Y.
The xy's do cancel, good. And so I'm left with y plus x over 2x minus y. Okay? Any questions on that? One little tidbit has nothing to do with that problem. If you have x minus 1 over 1 minus x, are those the same?
No. He's
No.
subtraction order matters.
Okay, they're not the same. But if I took this bottom one and I factored a negative 1 out of it, what would this become?
Positive 1.
Positive 1. What would this?
Positive X.
No.
You'd have to factor a negative 1.
If I took a negative 1 out of this, I would get a negative 1. What's negative 1 times negative 1? Positive 1. That's what I started with, right? If I took a negative 1 out of that, what do I get? A positive x. And so I'm going real slow here to show you what's happening. And now it's adding, so I'm going to switch them around. X minus 1.
Do you want us to write this?
Only if, you think you can't remember it. Yes, you should write it down. They both have an x minus 1 now, don't they? And so they cancel. I'm left with 1 over negative 1, which is negative 1. Okay? So, the reason I want you to see this is when you see the same numbers, but they have the different sign, or they're switched around, simply factor a negative 1 out of one of them. And then you'll get the same factor, like we did here. Okay? And you'll have a negative 1 line. And that will probably happen.
So if it always looks like that, do you even have to do the problem because you know it's going to be negative 1?
I just took one little concept that might be part of a bigger problem.
Yeah.
So there might be other stuff there. And maybe I have a 2 in front of each of these. I'm taking the negative 2 out.
Oh.
Okay, pointing at these two here. Okay? So it's possible that there's more stuff involved. But at some point in your factoring, you may end up with this concept. It may not look exactly like that, but it might be that, or it will be that concept. And so we have the same numbers top and bottom, they're just switch signs. And so to switch those signs back so we can simplify, just factor a negative 1 out, and then you can simplify. Okay? All right, any questions on that? All right. I know I give you minimal problems anyway, but I haven't done the rest of the calendar, so we'll stick with the assignments we have, and with this was because they are related, and I saw as an opportunity to get our test done before Thanksgiving break. So I don't know exactly what I'll do tomorrow, but work hard on it now, and then we'll have some more time somewhere. Okay. I'm gonna look back at my my calendar that I haven't put online yet, but I've looked at. I think it was 3 to 30, and then 4 to 48. So it was 10 and 12 questions.
Like threes and fours.
Let's do, yeah, 3s and 4s, yeah. In 9-4, let's do this. Let's do 5. 11, 17, 19, 29. Can you repeat what I just said? Oh, sorry, let me get started. 5, 11, 29. So this is 9-4. Okay? Now, if you don't get it with those few examples, then you're going to have to sit down and do a few more. And then on 5, let's do 6, 12, 21, 29, because that really looks ugly. 35, 44. And so tell me please what they were.
6, 12, 21, 29, 35, 44.
Okay, that reduced it a little more. There you go.